Hey Python starters, welcome. So today we are going to talk about linear programming and solving linear programming problems with PuLP in Python. So a great example of this is in 2014 there was a paper published about minimizing the number of staff required at a hospital, and you'll see a link to this article below the video here in the description. And an algorithm was used in terms of creating a set of linear functions and variables to describe uh, the staffing model. And then linear programming was used to minimize the number of staff required and to estimate the most optimal staffing solution. So here you can see in this table, there's an example. It shows the different 4-hour time windows. For example, 6 a.m. to 10 a.m., and the minimum number of nurses needed to serve the patients who would be expected at that time of the day. And so we can take this information and we can load this into an Excel model. And so here I've taken this information, put it into an Excel, and the goal is to solve this objective function and minimize this to figure out what is the minimum number of nurses we would need to staff in order to have enough nurses working each 4-hour time window to serve the patients expected at that time. And so this is in the Coimbatore City Hospital, one of the city hospitals there. And you'll see that I've put a description of the problem up here, and then I've listed out the different 4-hour time windows over here on the left, and then the different shifts that a nurse could potentially work. So nurses work for 8 consecutive hours starting at the beginning of one of these 4-hour time windows. So for example, from 6 a.m. to 2 p.m. And the way that we denote that is with a 1 for the 4-hour time windows that they work as part of that shift. So for example, shift 1 would be these first 2 4-hour time windows, and so on throughout the day until you get to this late night shift where they may start at 2 a.m. and go until 10 a.m. the next day. Now you'll notice the cells in blue represent the inputs. These are constants that we provide as inputs. This is what are kind of the input values. And then you'll see one of the requirements over here is the minimum number of nurses required for each 4-hour time block over on the right-hand side. And then in yellow are the variables. So the number of nurses working a particular shift are listed down below here. And these are initially just estimates or just initial values, and these can change over time because these can vary. And then in the orange is our objective function, which is simply the sum of this entire row of all the different nurses who work different shifts to give us a total number. And I've put some ranges, I've defined some ranges in Excel, and you can see the range names are explained over here. So if you come under here under formulas, you can go to the name manager, and you'll see these different names, groups of values, and the named ranges. And so I just list those here for reference so it's easy to see. Then we install Solver, which is an Excel add-in that you could enable. And there's links here to more information about that article, as well as to a link about linear program if you want to learn more about linear programming. And we can go into Solver now. Once we have this all set up, we can come in here. Okay, so in solving linear programming problems in Excel, we're going to use Solver. So we're going to go to Data and Solver. And you'll notice I have the Solver parameter, which is the objective set, which is the objective function, cell I11 here. This is the thing we're trying to minimize in this case. And we're going to change these variable cells, the number of working staff during for each of those shifts, subject to these constraints. So first of all, each of the number of staff working during a shift has to be an integer number. It can't be half a person. And then it has to be greater than or equal to the minimum number of nurses who need to be on staff at a particular time. Okay, so let's go ahead and solve this and see what Excel comes back with. Okay, it's found a solution. And there it is, 295 nurses, and it has a number of nurses working each shift to give us that total. And then let's see if it's met each of the constraints. So yes, it looks like each 4-hour window has at least the minimum number of nurses working. Okay, so how do we do this in Python? So in Python, we can use PuLP. So we can install PuLP, which I've done here by using the pip install PuLP command that will download and install PuLP on Windows. And there's a similar set of steps for to do that on Linux. Okay, so next we're going to write a Python program to use PuLP to solve this linear programming problem. So we'll import the PuLP module, and then we'll set up a problem object using the PuLP LP problem, and we'll add a string here explaining what it is, nurse staffing, and we'll use the pulp.lp minimize to indicate that we're trying to find a minimum value for this objective function. Next, we will create variables to represent each of the different shifts. So shifts 1 through 6, we'll have variables for each of those. And next, we will define the objective function by adding up the total number of nurses for each shift to the total number of nurses. And the way we do this is we take the problem object, the prob, plus equals, which is simply shorthand for saying equals prob plus each shift. And then we'll add the 6 constraints for each of the different 4-hour windows. We will add shift 6 and shift 1, for example, for the first 4-hour window, saying we have to have at least 70 as the minimum number of nurses to staff the 6 a.m. to 10 a.m. block, and so on. And we'll just add those shifts together to make sure we have the minimum number to meet the number of patient needs at that time. And then we'll use the solve method on the prob object to come up with an optimal solution, and PuLP will use its choice of solver. Then we'll take a look at the status to see, did we find an optimal result? Next, for each of the variables, we'll go through and print the name of the variable, so the shift and the number of nurses working that shift, and then we'll print out the total number of nurses by looking at that objective object on the prob object and converting that to a string. Okay, so let's go ahead and run this and see what happens. All right, so it came up with an optimal value, and it provides some numbers here. Now note that the number of nurses working each shift is different than what we found in Excel, but they're whole numbers, which is good. And the total number is 295, which matches what we had in Excel. And what's great too is that also matches what we saw in the paper, where they were able to minimize the number of staff and came up with 295 as the result. So there you can see, this is one way to do this is to write it out or model it in Excel, and then to take that and convert it into Python script, and using PuLP, we can automatically solve this. So let me know if you have any questions. Just add those to the comments below this video, and let me know if you'd like to try some other linear programming problems, or if you have questions about linear programming in general, or about Python or about PuLP, because we used a number of fairly advanced Python language fundamentals here. And so let me know if any of those confused you. Happy to dive into those deeper, and look forward to seeing you again soon.